Welcome to the FEMAP 10.2 What's New video series. In this video we'll be looking at a new method of performing a frequency response analysis inside FEMAP. The forced response capability inside FEMAP will perform a frequency response analysis based on modal results from any solver and produce sinusoidal responses to forces, moments, and elemental pressure forces directly. This interactive approach makes setting up models for dynamic analysis much easier and provides quick turnaround times for dynamic behavior investigation. So, starting from a normal modes analysis of this bracket model that's already been completed, we can investigate the dynamic behavior due to a unit loading input at the center of the large spider element. Initially, the unit loading with loading function is defined. The point of interest with this example is the node that has a mass element applied, which represents the center of gravity of a component fixed at the hole. The resulting vertical displacement at this point is the only output desired from the analysis. So we create a group accommodating that single node that will be referenced later on in the output setup. With the model setup completed, we can turn to setting up the dynamic analysis. For this investigation, we are only interested in including the first few frequencies in the response calculation. We also need to define the range of frequencies of interest for output. Various methods are available for defining the frequency range based on the Nastran type freq input entities, and we can define a broad spectrum in 5 Hz steps, and a more detailed range close to the first natural frequency, and finally add a point at the first natural frequency itself. Then we need to pick up on the group and specify the desired nodal and elemental output. With everything now set, we can select OK and submit the analysis to run. As we are only collecting data for one point, the return is almost instantaneous, which shows the real value of the interactive nature of performing this kind of analysis. We'll view the results in an XY plot, showing the Z displacement of the center of gravity node over the range of frequencies requested. You can see that the unit forcing function produces a maximum Z displacement of 1.8 mm at the center of gravity position right at the first natural frequency of the bracket structure. So you can see that the FEMAP forced response analysis is simple to set up, gives you full control of results types and entity selection for which results are calculated. The interactive nature of the workflow allows a quick turnaround time and lets you investigate the dynamic behavior of the design quickly and effectively. To learn more, visit us at femap.com or call your local FEMAP channel partner.